Formula for time period of a simple pendulum is given by 2 pi times square root of the quantity L over G, where L is the length of the pendulum and G determines gravitational strength at the location where pendulum is swinging. We will look at this formula conceptually and try to develop physical intuition. Let's look at the setup first. This dotted line marks the equilibrium position of the system. Right now in the picture, pendulum bob is pulled to the right. Angle theta shows the amplitude. Once released, pendulum will oscillate on this arc. Two forces act on the bob, tension and weight. Vectors shown in green here are components of weight. Restoring force is provided by component of weight perpendicular to the string. I will refer to it as just the restoring force in rest of the video. What parameters can we change in this system? We can increase or decrease the amplitude. We can use a shorter or longer length of the string. We can increase or decrease mass of the bob. We can change gravity by changing location. Let's see the effect of changing amplitude on time period. We have same length, mass and location. Only differences in the amplitude of these two pendulums. Different displacement of same masses means different restoring forces. Different forces on same masses means different accelerations. Pendulum on the left has smaller acceleration, so it moves slowly, but it also has to cover less distance. It so happens that less distance compensates for smaller acceleration and time period is not affected. Similarly, the second pendulum on right has bigger acceleration and moves faster, but it also has to cover more distance. Here again, more distance offsets higher acceleration and time period is not affected. Amplitude and period are not related. Amplitude has no effect on period of the pendulum. That's why amplitude does not show up in the formula of period. How does length affect time period? We have same amplitude, mass, and location. Only differences in the lengths of these two pendulums. Same displacement of same masses means same restoring force. Same force on same masses means same acceleration. At equal acceleration, shorter pendulum will cover the distance on smaller arc quickly. Longer pendulum has more distance to cover, so it takes more time. Thus, period of longer pendulum is more. Length and period are directly related. If length increases, period also increases. If length decreases, period also decreases. What about effect of mass on period? We have same amplitude, length, and location. Only differences in the masses of these two pendulums. Same displacement of different masses means different restoring forces. Pendulum on the left has smaller restoring force, but it also has less mass and thus less inertia to resist motion. It so happens that less mass compensates for smaller restoring force and results in same acceleration as that of the bigger mass. This second pendulum on right has bigger restoring force, but it also has more mass and thus more inertia to resist motion. Here again, more mass offsets bigger restoring force, resulting in same acceleration. Both pendulums have to cover same distance at same acceleration. This means both will take same time. Mass and period are not related. Mass has no effect on the period of the pendulum. That is why mass does not show up in the formula of period. How does gravity affect period of pendulum? We have same amplitude, mass and length, only differences in the location of these two pendulums. Left pendulum is located somewhere with less gravity than Earth. Let's say Moon. So this pendulum's weight on Moon is less. Right pendulum is on Earth. Same displacement of same masses but different weights means different restoring forces. Different restoring forces on same masses means different accelerations. Left pendulum has smaller acceleration than the right pendulum. Left pendulum gains speed slowly. So to cover same distance, it will take more time. Thus, period at less gravity is more. Right pendulum will cover the distance quickly because its acceleration is more. Thus, period at high gravity is less. Gravity and period are inversely related. If gravity is weak, period increases. If gravity is strong, period decreases. So the conclusion is period is independent of amplitude. That's why amplitude is not present in this formula. Period is directly dependent on length. That's why length is present in the numerator here. Period is independent of mass. That's why mass is not present in this formula. Period is inversely dependent on gravitational strength. That's why g is present in the denominator here.